Imagine this. An election is only weeks away. News anchors announce that candidate A is leading candidate B 52% to 48%. But how can anyone possibly know what millions of people will decide? Simply by calling a small group of 1,000? At first glance, it feels impossible, as though one were trying to guess the flavor of an entire pot of soup after only tasting a spoonful. And yet, remarkably, that spoonful often works. The secret lies in representation. Pollsters are like chefs tasting soup. If the soup is stirred properly, one spoonful reflects the flavor of the whole. If the spoonful is taken only from the salty bottom, however, the result is misleading. In polling terms, if you ask only men in their 70s about their vote, you have ignored women, young adults, minorities, and urban professionals. A truly useful poll depends on a sample that represents the entire population, male and female, young and old, urban and rural, across ethnicities, income levels, and political leanings. Statistics makes this even more surprising. You do not need millions of people to make an accurate estimate. A carefully chosen group of about 1,000 respondents can, under the right conditions, reflect the opinions of hundreds of millions with an error margin of just about 3%. The reason is probability. Think about flipping a coin. Flip it 10 times and you might see 7 heads, 3 tails. That does not look balanced at all, but flip it 1,000 times and the distribution will almost certainly approach 500 to 500. The larger the number of trials, the closer the sample comes to the truth. Polling uses the same principle. Once a sample reaches a certain size, the benefit of adding more people quickly diminishes. Beyond that point, representativeness matters much more than size, but randomness is far trickier in practice than in theory. People who answer their phones on Tuesday mornings are not random. Reddit users are not random. Train commuters, retirees, or university students do not stand in for an entire nation. True randomness is elusive. That is why pollsters use stratification. They deliberately match their sample to the actual demographics of the country. If 52% of the voting population is female, 52% of the poll should be 2. If 13% of voters are black, the same percentage should appear in the survey. After gathering results, pollsters then weight the responses so that the influence of each group mirrors its role in the real electorate. Weighting is the so-called black magic of polling. Imagine 2 groups, white men over 55 and black men under 35. In one city, they might be the same size. But historical records show the older men are more likely to vote. If pollsters treated both groups equally, the prediction would lean toward the younger group more than reality. Weighting adjusts this imbalance. Responses from less likely voters are given less statistical weight, while responses from frequent voters are emphasized. These weights are informed by past turnout, census data, and local records. But weighting introduces risk. If a group turns out in unexpectedly high numbers, young voters suddenly flooding the polls, the weighted model may underestimate their influence. That is why polls sometimes surprise us, even before the math. There is the delicate art of wording. Consider 2 questions. Do you support reproductive rights? And do you favor unlimited abortions? Both refer to the same policy. But the phrasing can lead to drastically different responses. Neutrality in language is as critical as neutrality in sampling. The way a question is asked can tilt an answer as surely as the way a spoon is dipped in soup when pollsters present their results. They include a margin of error and a level of confidence. A poll might state that candidate A leads 52 to 48 with a margin of error of plus or minus 3%. This means that if the poll were repeated many times, 95% of the time, the result would fall within 3 points of the true number. Candidate A could in reality have anywhere from 49 to 55% support. That is why close elections are so difficult to call. The uncertainty zone swallows up the apparent lead. Polls are not crystal balls. They are estimates with known boundaries of reliability. The most counterintuitive part is that the accuracy of a poll depends more on randomness than on size. Surveying 1,000 people across the country at random is often more accurate than surveying 10,000 in a single city. It feels absurd that so few can stand for so many, but the mathematics is clear. Once the sample is large enough, adding more people adds very little precision. Survey 1 million, and the margin of error shrinks only slightly compared to 1,000, though the cost skyrockets. Yet randomness has another obstacle: human behavior. Some groups are harder to reach. Young people often ignore phone calls. Immigrant communities may hesitate to respond due to language barriers or distrust. Conservatives who dislike mainstream media may refuse to answer altogether. Pollsters must constantly innovate, using text messages, online surveys, and mixed modes to cast their net wider. But no method captures everyone equally. Every poll has bias. The skill lies in reducing it as much as possible. All of these complexities explain why polls sometimes fail. If a group turns out in higher numbers than expected, predictions can collapse. If people hide their true preferences, accuracy falls. If the weighting is misapplied, or if the questions are poorly worded, errors multiply. We have seen high-profile elections where polls predicted one outcome and the voters delivered another. So why trust polls at all? Because despite imperfections, they often work better than chance. Much better. They function like weather forecasts. No one expects a forecast to be perfect, but a 70% chance of rain tomorrow is more informative than a blind guess. Polls give probabilities and trends, not certainties. They tell us which way the wind is blowing, not the exact gust that will hit our window. Understanding this changes how we read polls. Instead of treating them as ironclad predictions, we can see them as signals. They tell us the mood of the electorate, the direction of public opinion, and the probability of outcomes. They guide campaigns and farm journalists and give citizens a sense of the political climate. But ultimately, they remain estimates, useful but limited. So how do pollsters call a small subset of people and make it reflect the whole electorate? By carefully constructing a representative sample, weighting responses according to past patterns, phrasing questions with care, and applying the laws of probability. It is not magic, though it can look that way. It is statistics, applied with craft and judgment. And sometimes, with a dose of luck, the next time you see a headline poll, resist the urge to take it as destiny. Look at the margin of error. Consider the sample size and the methodology. Polls are windows, not mirrors. They offer a glimpse of the collective mood, but never the whole picture. And remember, elections are not decided on the phone, but at the ballot box. In the end, polls teach us something profound about both science and democracy. They reveal that the vast complexity of a society can be captured in patterns, that 1,000 voices can speak for millions if chosen carefully. and that asking questions with rigor is one of the most powerful tools we have. Like the spoonful of soup, a well-constructed poll shows us the flavor of the whole. It is not perfect, but it is a reminder that knowledge often comes not from certainty, but from carefully measured approximations.